Today, we will be talking about the trends in hyperscale and FADU's E1.S Cloud SSD offering. My name is Anu Murthy, and I am VP of Marketing at FADU. Let's talk about FADU's roadmap and what's driving it. COVID-19 entered the world, dramatically changing the storage landscape. This initiated a rapid shift to work-from-home lifestyles, which stretches the infrastructure bandwidth. Hyperscalers have had to expand infrastructure in a way never seen before, in servers, storage, and networking. This expansion in infrastructure accelerates moving the remaining on-premise mission-critical functions into the cloud. To do so, they put in infrastructure to absorb latency-intensive functions. To maintain coherence with the edge, the main hyperscale infrastructure has to expand its bandwidth in a way never seen before. This is what is accelerating the generational adoption from Gen 3 to Gen 4 to Gen 5 very, very rapidly. Now let's take a look at the server and storage CPU roadmap and how they adopt PCIe generations. AMD was early to the market with PCIe Gen4 in 2018. Intel was a little late to the market with Ice Lake in 2020. To make up for it, Intel will introduce Sapphire Rapids, which has PCIe Gen5 in 2021. The high-end cloud servers are the first to adopt any new PCIe generations because they're compute intensive and their bandwidth to storage is a very, very important facet to their performance. They will be followed by mainstream and low-end servers and storage. Some storage may not need the bandwidth and will move from Gen 3 to Gen 5 directly. In 2016, 25% of enterprise SSDs were deployed in cloud data centers. In 2024, this percentage moves up to 80%. OCP 1.0 Cloud specification addresses the requirements of the cloud. The two dominant types of workloads seen in the hyperscale data centers are infrastructure and streaming workloads. The infrastructure workloads are driven by multiple applications such as virtual desktops, email servers, cloud suites, all of which demand very high sequential and random performance. They require a 24/7 operation and sustained QoS to meet SLAs. The mission-critical and edge applications are extremely latency sensitive, and the corporate applications demand security. Streaming workloads, on the other hand, have average low performance requirements but peak demands for access to apps and data. These workloads demand burst and trim performance, random read performance, and a sustained QoS. The E1.S specification addresses these by picking out the common requirements of the workload and putting them in the base specification, and the appendices document the differences in requirements. That makes it much easier for controller vendors such as us to organize our controllers and firmware to be much more effective. Starting 2020, there will be an unprecedented fall in NAND flash pricing, which will last right up to 2022. This is in part due to COVID oversupply and soft demand, transition from 96 layer to 128 layer, and the addition of YMTC supply. As you can see from the graph above, QLC is headed from 7.5 cents a gigabyte in 2020 all the way down to approximately 3.5 cents a gigabyte in 2024. It also accounts for 27% of the supply in 2024. This makes the conditions ripe for the adoption of QLC SSDs eating into the HDD space. ZNS, the same streaming interface for HDD and SSD, which sequentializes traffic before it writes to media, will enable the use of QLC NAND in a big way. There are two flavors of ZNS, one that permits fast backup for high-speed random access data, and the other one that just reduces over-provisioning. Both these flavors are seeing rapid adoption in the industry today to enable QLC adoption. What is the effect of all these on flash controllers? As a percentage of the SSD cost, the flash controller cost is increasing. Design efficiency, in this case, is pretty critical. Generational scalability enables a higher total cost of ownership. Broad NAND flash supplier base is essential for hyperscalers, and its compatibility further enables rapid and flexible SSD introductions. Workload customizations become key, and telemetry customizations are required for maintenance and supply chain. At FADU, we introduced our flagship Gen 3x4 Bravo SSD. It is a high-performance, low-power SSD. We will follow it up with early 2021 to meet the Ice Lake with a Gen 4x4 SSD. This Gen 4x4 SSD will support both enterprise as well as hyperscale flavors. It is a dual port with an E1.S and a U.2 form factor. And in 2022, we will follow it up with Delta Plus to meet the QLC SSD, which is able to bear a little more loading, and an Eco Gen 5x4 to meet the high performance requirements of Gen 5. At FADU, we were the earliest to recognize the potential of OCP 1.0 specification and the E1.S SSDs. We were one of the earliest in the market to implement the Bravo E1.S SSDs in our Gen 3 and follow it up with an announcement for a Gen 4 Delta SSD in the E1.S form factor. Now let's talk a little bit about FADU Bravo, our Gen 3 storage platform, and its successes. This table shows the performance of the FADU Bravo Gen 3 E1.S SSD at 7% OP against the current leader in the market. We far exceed the performance of the current leader in the market in this class by quite a bit. Our sequential write is 3.3 gigabytes per second as opposed to 3 gigabytes per second by the current leader. Our sequential write is 2600 gigabytes per second. Our random read is 800K IOPS per second as opposed to 480 as displayed by the current leader in the market. And our random write is approximately 90K IOPS. Our K IOPS per watt is 130, which is approximately twice as effective as the current leader in the market. In the previous slides, we discussed two dominant hyperscale workloads. This slide shows FADU Bravo Gen 3's performance in such workloads. On the left-hand side, we show Bravo benchmarked against the current leader in a synthetic IaaS workload with a 4K random read and a 5% sequential write injection. As you can see, FADU far outperforms the current leader, particularly on the higher nines. This shows very stable QoS and makes it a very apt device to use for writing good SLAs. On the right-hand side, you see a data center streaming application with mostly random read and large surges of sequential write. You can see that the market leader is in blue and it has higher overall latency as well as QoS. FADU below shows a much lower average latency and a much better QoS. FADU Bravo Gen 3 has been qualified with multiple NANDs. We've qualified it with Kioxia, Micron, and SK Hynix NAND. We've passed multiple qualifications with hyperscale vendors, T2 Cloud, OEMs, and SSD suppliers. FADU Bravo Gen 3 supports hyperscale cloud storage and OEMs. In this section, we will talk about FADU DELTA Gen4 E1.S SSDs. Introducing DELTA Gen4 platform. On the DELTA Gen4 platform, we support PCIe Gen4x4, PCIe Gen4x2, PCIe Gen3x4 or PCIe Gen3x2. We support the NVMe 1.4a specification and the OCP 1.0 specification. We support NANDs of different types, eTLC, CTLC, QLC NAND, and XL Flash. And we support up to 16 terabytes. Our random read performance is 1675 K IOPS, and our sequential read performance is 7 gigabytes per second. Our random write performance is 450 K IOPS, and our sequential write is at 5 gigabytes per second. We also support E1.S and M.2 form factors for the Hyperscale cloud. With Bravo SSD, we established ourselves as the leaders of this class in the low-power, high-performance SSD. We beat competition in almost all of these categories. With DELTA Gen4 SSD, we consolidate this lead by doubling in every performance parameter. We double our capacity, our sequential read, sequential write, random read, random write. But in power, we consolidate our leadership by only consuming 1.5 times the power of the previous generation. The leading vendors in the industry have announced their Gen 4 drives. Their performance is in the table on the left side and the FADU Delta's performance on the right-hand side. As you can see, in every category, we beat the performance of the competition. On sequential read, at FADU Delta, we're about 8% faster than the competition. On random read, we're up to 197% faster with FADU Delta. Our K IOPS per read far exceeds everybody else in the industry. On sequential write, we're up approximately 209% faster. On random write, we're approximately 500% faster. Our K IOPS per write is much better than anyone in the industry. Our power remains much lower than the rest of the industry. The Delta SSD supports a number of features for the data center. We support the E1.S form factor with 9mm heat spreader, 15mm and 25mm heat sinks. We also support the M.2 form factor and we're compliant with the OCP Cloud Spec. We support multiple firmware slots, low latency at low queue depth, a world-class sustained QoS to 6 nines to meet SLAs, ZNS with AOS, great burst and trim performance. This slide shows our schedule for the Delta SSD release. In Q1 2021, we're able to distribute engineering samples of our Delta SSDs. In Q2 2021, we will have customer samples. The first samples to come out will be in the E1.S, the U.2 form factors, and they will support eTLC, followed by possibly E3 form factor and CTLC, QLC, and XL Flash as required. Established ourselves with our Gen 3 FADU FC3081 controller. We've provided a stable, customizable codebase which has worked seamlessly in a variety of environments. We've ported our codebase to SK Hynix NAND and Kioxia NAND Flash from the charge trap variety, as well as Micron B27A from the floating gate variety. Our Gen 3 controller has been qualified by 4 major vertically integrated NAND flash suppliers, 2 other flash SSD vendors, and 2 white box vendors. Our Gen 4 controller is ready for qualification in 2021. We have 3 flash supplier choices: SK Hynix, Kioxia, and Micron. At FADU, we have flexible business engagement models. First, we have a turnkey design model where FADU supplies the SSD design, controller, and firmware, and the OEM builds their own SSDs and may customize the firmware. We also supply a consignment model where FADU supplies the SSD controller, design, and builds private labeled SSDs. The OEM consigns their NAND flash to us. And the third is a channel to distribute FADU SSDs. Thank you.